This is sixth period. We are in the final section of chapter review. For those of you who are gone, we have 1 through 20 left to do, and we are going to go forward this time, I think the class says. They want to start from the beginning and then just meet in the middle. So, starting with chapter 5, number 1. They give us two functions, this one here, and they want us to do this to it. What does that mean? Subtract, right? Subtract. Okay, so I'm just going to write 2x squared plus 4x minus 6, and you are subtracting 2x minus 2. Yeah? I put them in parentheses like that because the minus sign you have to be careful of. You have to distribute him through. So not for this piece, this 2x squared plus 4x minus 6 stays, but this minus goes negative 2x plus 2, excuse me. And then what? Combine like terms. Yep. So 2x squared is the only square. He's done. I cross him off. 4x minus 2x is another just 2x. And negative 6 plus 2 minus 4. And that is it. Okay, good? All right. Same functions again, except this time they're wanting you to do this. What does this mean? Multiply. Okay, that is different than this right here, this symbol in number 3. What is the symbol in number 3? It's called a composite function. You're composing one inside of the other one. So there's a difference between multiply and compose. We'll talk about both of them, but the first one is multiply. So we want to multiply those together. We've got something that is 3 pieces times something that is 2 pieces. Okay, so how many pieces should I end up all together before I simplify? 6, right? 3 times 2 is 6. So I should have 6 pieces. Okay, so the first thing I'm going to do is take this guy times the 2x. 2x squared times 2x. What's that make? 4x to the third power, okay? Then I do 2x squared times negative 2. It's going to be negative. Negative 4x squared. Okay, now he's done. I'm going to start with this 4x, and I'm going to do that for both of these. 4x times 2x plus 8x. 4x times negative 2 minus 8x. Something happened weird. 4x times 2x, that should be squared, right? Yeah. Okay, then negative 6. Negative 6 times 2x minus 12x. Negative 6 times negative 2 plus 12. There are 1, 2, 3, 4, 5, 6 pieces. And I put them all together. So I only have 1 x to the third power, and there's 4 of those. Okay, so he's done. These both are x squared, so negative 4 plus 8 plus 4x squared. Cross them off. Okay, negative 8x minus 12x. What's that make? Negative 20x. Those are done. And then plus 12. Yeah? Beautiful. There you go. That is multiply. Okay, good? Okay, now this one. G composed of f of x. It does matter what order these go in. Okay? If it's G composed of f, that's different than f composed of G. But G composed of f, which one goes inside of the other one? Which one is the inside function? F is on the inside, right? F is closely related to the x. So this goes into G, right? That's what's inside. So F right here is going inside of G, right there. In the x, actually. I'm kind of pointing to the 2, but it goes into the x. So the G was before 2x minus 2, right? But instead of putting x, I'm going to put that big chunk of junk in there. Okay? Does that make sense? Okay, and then I'm going to simplify. So this whole chunk goes in here. 2x squared plus 4x minus 6. And then we simplify. Okay? How do we simplify? Distribute the 2. So let's do that. Okay? So 2 times 2x squared, 4x squared, 2 times 4x plus 8x, 2 times negative 6, negative 12, but then I have this minus 2. I don't distribute that 2 to that 2, right? He's not in the parentheses. So then I just combine like terms. The only things that will combine is the negative 12 and negative 2. So 4x squared plus 8x minus 14. Okay? Good? Questions about that? That's that composite thing, okay? They might write that rather than writing GOF, it looks like an O, but it's not really an O. They might call it, or they might do this instead. You remember that thing? Where the f of x is inside parentheses. They might do that instead. That means the same thing, okay? Again, that's not multiply, that's composite, okay? So multiply is here, composite is there, all right? Now, in number 4, this is another composite, but they're actually having you plug a 2 in, okay? So, do you remember how to do these? You plug 2 into G, because that's the inside function first, right? We're going to plug 2 into G. Okay, so let's do that. Let's do G of 2. Plug 2 into G. 2 times 2 minus 2. That's a lot of 2's. And that becomes 2 times 2 is 4, or minus 2 is another 2. Holy crap. Then we plug that number into which x? All of them. You actually plug it anywhere you see an x, okay? So we're going to plug 2 in for all of those x's. Okay, we're going to plug 2 into all of those pieces, and we should just get one final answer. So what do you do first? Square the 2, this becomes 4. 2 times 4 is 8, plus 8 minus 6. 16 minus 6, 10? 10. 10 to 10. All right, the next one. 5 and 6 are both the same type of problem. Find the inverse. How do you find the inverse? Yep, there are 4 steps. The 4 steps, I'll write them off over here. The first one, step number 1, f of x becomes y. Step number 2, the x and the y switch with each other. What do you do in step number 3? Solve for y. And then step number 4, y becomes f inverse of x, and that's that negative 1. Ooh, we see that. We've seen that before. Just recently, right? That negative 1. You know, like the sine negative 1, right? Sine, inverse cosine. Okay, that's inverse. Inverse sine, inverse cosine, inverse tangent. Yeah, that's that negative 1 thing, right? Okay, so we're going to do these steps on this one. So step number 1 says we change it to y. Y equals 1/2 x plus 3. Okay, if you want to just skip straight to step number 2 and flip those 2 around, that's fine. X equals 1/2 y plus 3. Okay, now I unwind him and I'm solving for y. What are you going to do first? Minus 3. So subtract the 3, subtract the 3. Can you subtract 3 from x? Yeah, it'll just become x minus 3. Okay, equals 1/2 y. And then what? Yeah, you're dividing by this 1/2, but easier than that, Michelle says, times 2. Okay, so we're going to multiply the 2 by the 1/2 to get it to go away, and you times 2. Y equals 2x minus 6. Make sure that you distribute that 2 through both of those pieces. Okay, so, and then the last step, step number 4, I'm going to flip these 2 around. Can I do that? I don't like that y to go first. 2x minus 6, but I'm going to call him f inverse of x. That's his inverse. Okay? So this guy is going to undo what this one does. Right? Those two undo each other. Like ln and e. ln and e are inverses of each other. They undo one another. Okay? Which we're going to get to here in just a minute. Okay? All right, next one. Find the inverse of that thing. Okay? So we're going to skip some steps here. Let's skip straight to step number 2. G of x is going to become y, and then we're going to switch x and y. So this will now be x equals 3y over 2 minus 12. Yeah? Good? Okay, then what? Add 12 plus 12 plus 12, and that will become x plus 12 equals 3y over 2. Okay, and then what? Times 2 times 2. So he's gone, and I'd like to put the x plus 12 in parentheses so I remember to distribute that for both pieces, and not just do 2x. So this will be 2x plus 24 equals 3y. Okay, and then what? Divide by 3. Okay, when you divide by that 3, make sure you divide all 3 pieces by 3, right? You're dividing all of it by 3. So y is equal to You can call that like 2/3 x if we want to shove the x off at the top. That's fine. Plus 8. Plus 8. Oh, shoot. I should have renamed it. F inverse of x equals 2/3x plus 8. There we go. Okay, good? All right. Now these next two kind of go together. This one is graphing a square root, and this one is graphing a cubic root. You see this little 3 right here? Okay. What does a square root look like if you don't move them around at all? Dot at 0? Yep. And then it goes like that, basically. It kind of has a little bit of a curve, I guess. A little bit of a curve. Okay. Now this one, number 8, is a cubic root. What does he look like? Kind of the same thing, but he's back the other direction also. Okay? So it kind of looks like that. All right? Do you remember why he goes back the other direction? Why doesn't the square root go back the other direction? Because you can't have a negative square root. Can you take a cubic root of a negative number? Yep, you sure can. Okay, so this is what just the square root of x looks like, and this was just the cubic root of x looks like. So let's figure out what the graph of these guys. The plus 5 and the minus 3, what are those doing to the function? What does it do to this guy? Left 5, because plus 5 actually means left 5, right? So that's the opposite of what you think. Opposite sign, right? Opposite sign, and then this is down 3, okay? So this guy was at 0, 0 before. So when I go over here to graph him, 0, 0 before. Oh boy, you can hardly see. This is where 0, 0 lives, right there in the dead center. So I'm going to go to the left 5. 1, 2, 3, 4, 5, and down 1, 2, 3. And then he's going to do this. Okay, so left 5, down 3. This is negative 5, comma, negative 3. That's that dot. Okay, negative 5, negative 3. Then they want the domain and range. Last thing, domain and range. Okay, so domain is x's, right? Left and right. Will he go to the right forever? Yes. Will he go to the left forever? No. What's the farthest left he goes? The farthest this way. Negative 5. So x has to be what to negative 5? Greater than negative 5. Will he touch negative 5 exactly? Yes, because there's a closed dot on negative 5. So he is x is greater than or equal to negative 5. Okay, range is up and down. Will he go up forever? Yes, he'll go out and up. Will he go down forever? No. So what about y? Greater than or equal to? The lowest he goes is negative 3, right? Okay, good? All right, now this one. We've got 3 things going on here. This is what the cubic root looks like, and here's like the starting point at 0, 0. What does the negative 4 do? It goes to the right 4. Okay. What does the negative do? It reflects it, yep. Or flip. It flips it, and the 2? Up 2. Okay. So we're starting at 0, 0, which is right here. Let's go to the right 4. 1, 2, 3, 4. And let's go up 2, 1, 2, and then we're going to, instead of going this way, we're going to go the other way. Like that. It's going to look something of that nature, right? Like a curly QS. And here is this point right here at 4, comma 2. Okay? Domain and range. Yep, domain. He's going to go left forever. He's going to go right forever, so he is all reals. Range. Will he go up forever and down forever? Yes, so he is all reals there. Okay? Now, that will always, always, always be the case for a cubic function or cube root function. Okay? For a square root function, it will never be the case that it's all reals, right? It will never be all reals for a square root function, but it will always be all reals for a cubic function. Okay? Moving on. All right. Number 9. 9 and 10 are square root, cubic root. They want us to solve this thing. What are we solving for on number 9? X. We're solving for X. Yep. Okay? So we've got to move everything around so that the X is by itself, basically. That's all we have to do. Okay? What are you going to move first? Not yet. Not yet with the negative. Minus 3. We're going to subtract the 3 first. Okay? So we got negative the square root of X minus 11 equals 6 minus 3 is 3. There he goes. He's gone. Okay? Then what? Now do the negative. Yep. Now divide by a negative 1, divide by a negative 1. So we have the square root of X minus 11 equals 3 divided by a negative 1 is negative 3, right? Now to get rid of a square root, you square both. Yep. Now can you square a negative? Yeah, you can't take the square root of a negative, right? But you can square a negative, okay? So think of this as being in parentheses. If I square that square root, he kind of just goes away and it's just X minus 11. What is negative 3 squared? Is it negative 9 or positive 9? It is positive 9, right? Think of this guy as being negative 3 times negative 3, and the negative is going to go away. Okay, so that's 9, and then add 11. X is 20. Okay, you can plug that back in if you want to check your answer, right? You sure can do that. Okay. Number 10. We've got a cubic root, a 3, a minus 6, blah, 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 all that stuff. Solving it the same way, except it's a cubic root instead of the square root. What are you going to move first? Add the 6. Plus 6 plus 6, so he's gone. Okay. So I've got 3 and the cubic root of 3x minus 1 equals 6. Then, which 3? The one on the outside, right? Divide by 3. Divide by 3. Draw a line so I can make sure I don't have a mess here. 3x minus 1 equals 2. Okay, and then what? How do you get rid of a cubic root? You cube it. You take it to the third power, right? The third power. So this goes away here, and I just have 3x minus 1 and 2 to the third power. That means 2 times 2 times 2. And that is 8. Okay, and then there's just basic algebra from here. Add 1, so I have 3x equals 9. Okay, divide by 3, x is 3. And again, you can plug that back into the equation if you get stuck, or if you want to check, I guess. And there's that. Okay. Last section, chapter 6 is it. Exponential and log functions. We've just got one section left. 10 problems. These 20 questions are going to go fast, I think. Right? I was like, 20 questions. Whew, kind of nervous. But I think they're going to go fast. Does the following function represent a growth or a decay? But there's a 15. You're right. You're right. You're right. I just have to be the devil's advocate. Yes, this number right here is the only number that you're taking to the x power, right? The 15 doesn't matter because you're doing that afterward, right? You're taking it to the x power first. So because this number is smaller than 1, it's going to be a decay. She's right. I just have to give you crap. Okay? It is a decay function. I'll just say the base is less than 1. Okay? If it is a number that's greater than 1, it is a growth. Now, it's not that it's a fraction though, right? Because 3 over 2 is a fraction, and that would actually be a growth, right? Because 3 over 2 is 1.5, okay? So that would be a growth. All right, in number 12, use the equation. This is the equation for compound interest. So A, sometimes we call this P instead of A in the center there. Like that's the principal, right? Remember that? Principal. To solve the following, a car that is worth $20,000 is depreciating. That's an important word, depreciating. At a rate of 15% per year. So it is increasing or decreasing in value? It's going down, okay? Find the value of the car after 5 years. So where does the 20,000 go? Let's just pick this apart. 20,000. It goes in for like the A or the P, okay? That is the principal. 20,000 goes here, okay? And then I have 1, the rate. What is the rate? Yep, it's 0.15, okay? But Kelsey said negative. Why is it negative? Because it's depreciating, right? We get to choose plus or minus, okay? Minus because it's going down in value, right? And then we take it to the t power, which is 5, okay? So let's write out what this looks like before or when we simplify this inside of here. 20,000 times, what's 1 minus 0.15? 0.85 to the 5th power. Now this is my base right here. Does that tell me I'm doing a growth or a decay? A decay, right? That number is less than 1, and that's what we want to have happen, right? It's depreciating. So you should just be able to type that whole thing into your calculator. 20,000 times 0.85 to the 5th power. Do that. Or if you want to do 0.85 to the 5th power, enter times 20,000, that's fine. $8,874.11. So 5 years, my $20,000 baby of a car is now less than half of what it was worth before. That's depressing. That's very depressing. So I can only go back and sell it for like not very much. Yuck. Okay. All right, 13 and 14 kind of go together. Write that as an exponential function and write that as a log function, okay? I always use this as an example. If we have 2 to the 3rd power equals 8, right? That checks out. 2 to the 3rd power equals 8. That's an exponential function. EXP. If I want to write that in terms of log, I've got log, and what's the base on that log? If I change this into a log function. 2, the first number stays in the same spot, the second two numbers switch. So log base 2 of 8 equals 3. First number stays in the same spot, these two numbers switch places with each other, right? Okay, so that's what it looks like log exponential. So if I have log base 8 of 64 equals 2, I'm going to write that as an exponential function. 8 squared equals 64. On this one, it's hard to do this one wrong because just check and make sure that that answer seems reasonable, right? 8 squared equals 64. I'm not going to give you one that doesn't come out nicely, right? Okay, so kind of check to see that. If you accidentally write it as 8 to the 64th power equals 2, you're going to kind of know that that one's wrong. So there you go. That one should be kind of free points. That's an exponential function, okay? Now, this next one, 4 to the 3rd power equals 64. Log base 4 of 64 equals 3. That's what that looks like as a log. Good? Yeah? Okay. Number 15. Solve. 3 to the 4x equals 9 to the 3x plus 7. Now we have an equal sign. And these are two exponential functions that are equal to each other. Remember what we tried to do? Yeah, we want to try to get the bases to be the same number. So this 3 and this 9, we want to try to get those to be the same number. Okay? Now, 9 I know is 3 times 3, but we don't want to write it as 3 times 3. How do we write this to be the same base? Yeah, let's write the 9 as being 3 to the 2nd power, right? I'm just replacing that 3 to the 2nd power with 9. Okay, so that stays 3 to the 4x, and then that becomes 3 to the 2nd power. But then it already has a 3x plus 7. Okay, so we just write it like that, and then we're going to end up multiplying that through, right? Okay, so 3 to the 4x is going to stay the same. This guy, we're going to distribute that through, but then what happens? The 3's are going to cancel out. Okay, so I've got 4x is going to be equal to, if I distribute that through, what's that going to make? 6x plus 14. And I'm almost done. Yep, put the x's together, so minus 6x, which we're going to end up with a negative. That's okay. 4x minus 6x. Negative 2. And then divide by negative 2, divide by negative 2. X is negative 7. That's my final answer. Okay, good? Okay, number 16. Express that as a single log. Okay, there are two logs there, these two. And what's separating them? Subtraction. What does subtract mean in log world? What's subtract mean? It doesn't mean subtract. Divide. You're dividing, right? Okay, so I want to put those two logs together, and because of the same base, because they're both log base 3, I can put them as just one log. But it's not 81 minus 9. That doesn't become 81 minus 9. It becomes 81 divided by 9, right? Because plus or minus means divide. So if I write that as a single log, that's going to become simplified log base 3 of 9. Okay, now they want me to actually like solve what that thing is, right? Now just wait, don't plug it in. Set it equal to x, right? And let's write that as an exponential function. Yep, this means 3, the first number stays in the same spot, second two numbers switch, 3 to the x power equals 9. So what does x equal? 2, right? 3 squared is 9. There you go. All right? Yes, ma'am. I won't give it to you if the bases aren't the same. That's a very good question, though. So if the bases are the same, she says if this 3 does not match that 3, what do? Then you can't put them together, and that's just the answer. But I probably won't give that to you. Yep. You will be able to put them together here. So I'm just going to put over here a little side note. Minus means divide in log world, and plus means multiply. Okay, so when you put them together as one log, minus means divide, and plus means multiply. Okay, good? All right, 17. Change that to base 10. What is the base of it right now? 6, but my calculator doesn't think in log base 6. Some of you guys do, but what? Yes, so change it to base of 10. It's log base 10 of the big number, not necessarily the numerically big number, but like the one up here is, the one here goes here, and the base right now goes to the basement. Log base 10 of 6, okay? So it's not always the case that this is the higher of the two numbers, right? This is just where it goes, and then this number in the base goes to the basement, okay? So log, and you don't have to type in your calculator log with base 10, right? Your calculator already thinks in log base 10, so it's just log 31 divided by log 6. You need to write this step out. Otherwise, I won't count it right. Because I know some of your calculators you can convert to log base 6, but I want you to know that that's actually what this becomes, okay? So this has to be in part of your answer. 1.9, okay? Now, what this means right here, if we think about what that means, log base 6 of 31, log base 6 of 31, if I set that equal to x, that means 6 to what power will give me 31, right? Okay? I know that 6 to the first power will give me just 6, right? And 6 to the second power will give me 36, right? 6 squared is 36. So my answer has to be some number between 1 and 2. And it's pretty close to 36, right? 31 is pretty close to 36, so it's 1.9, right? Okay, so that seems pretty reasonable. All right, couple left. 18. All right, so we just had a problem where we had two exponential functions equal to each other. We have 8 and we have 30. Right before we had 3 and 9, and we wrote 9 as 3 squared. So 8 and 30 are the two numbers. So I know that 8 is like 2 to the third power, right? Maybe we can switch them down to 2's. 2 to the what power will give me 30? You think of anything? 2 squared is 4. 2 to the third power is 8. 2 to the fourth power is 16. Then 32, what? Nothing works. You can't get 30. You can't get 30. You can only get 32. So when that doesn't work, when you can't get them in the same base, you have to log both sides, right? Because this is an exponential function, and exponentials, exp, and logs, what relationship do they share? They're inverses, right? So we're seeing inverses now with logs. We found the inverse before, and then we see the inverses again when we do trig functions, right? Inverse sine, inverse cosine, inverse tangent. They're all over the place. Okay, so those are inverses of each other. So we have to undo them by putting log in front of both sides. Log undoes an exponential function. All right, so if I write all this out, it looks like log of 8 to the m plus 1 power and log, is equal to log of 30. What's the base of my logs? 10, right? Because there's no base, so we just assume it's 10. And now we can move the m plus 1 down in front, right? That's what the log properties say. M plus 1 can go down in front. Okay, so now he's from there, he's down in front now. I want to solve for m. I want to get that m by itself. You can't subtract 1 yet. Divide by log 8. We're going to kick him out of there because this is multiplied, right? We're going to divide by log 8 to get him to go away. Log 8. Okay, so I've got m plus 1 equals log 30 divided by log 8. What is that as a decimal? Log 30 divided by log 8. Remember that when you're plugging this in, if it opens a parenthesis here, you have to close that parenthesis before you do your division, right? What? Yeah, 1.64? Okay. You were doing it after you subtract. Okay, 1.64. Okay, and then we want to find just m, so we have to subtract 1. So m is equal to 0.64. There we go. Good? Okay, so you have to log both sides. When you can't get them to be the same base, you have to log both sides. Now let's say I did that problem, or I didn't realize to start with that this guy, I can make those guys be the same base. Could I have just logged both sides to start with? Sure, you can do it that way. Yeah, it's faster to create them to be the same base. But if you want to log both sides on these, that's a-okay, right? Okay. 2 left. Holy cow. This is going fast. Wow, we're speedy. Number 19, solve this. They're all log base 6s, so we are good to go. Except you can't just cancel all of them out. Right? It would be nice if I could just cancel, right? And just have 10 plus x equals 40, right? And then the answer would be 30, right? But that's not the case. This is one side right here. And what's separating those two logs? Plus, and what's plus mean? Multiply. So let's write that as one log together. So log base 6 of what? Yep, 10 times x, right? Those two are multiplied together. 10 times x. Okay, equals log base 6 of 40. Now, I can cancel the logs because they're on both sides. So those two cancel out. And then I get 10x equals 40. Divide by 10, x is 4. X is 4. Ooh, my little circle got out of control there. X is 4. Good? You cannot just cancel the log base 6s to start with, otherwise you'll get 10 plus x equals 40 and you'll say the answer is 30. That's not right. Okay? Last one. 20. He says e to the 5 ln 2 power. Yeah. E and ln will cancel with each other because exponentials and logs are inverses of each other, just like e is the inverse of ln, right? Those two undo one another, okay? So, e and ln will cancel with each other, but only if that 5 is gone. Okay, so a lot of people say, well, that 5 needs to go down in front. Well, he's already down in front of the log, right? You can't put him down in front of an e, okay? But what I can do is I can move him to the back, okay? So he looks like this. E to the ln of 2 to the 5th power. So we've got like an exponent and then an exponent on top of that. But those two cancel out with each other real quick, and then it makes 2 to the 5th power, which is just 2 times 2 times 2, 5 times. 32 is the answer to that. Holy cow, that was speedy fast. E, there is a button E. There's an E button. There's an E button on your calculator. Did you find it? Yeah? Perfect. Any other questions? Say goodbye, track people. And golf. Bo and golf. And who else? McLean? Okay, we didn't forget about you, Bo and McLean. And who else? Anybody else? Golf? Okay.